series where we'll look at Python with OpenCV. So where we left off, we did the half-line transform already. So today we'll be looking at the half-line transform, but the probabilistic version of it. So half-line transform is used to detect shapes and represent them as a mathematical form, which is a line. So you can detect the different shapes, and even if it's distorted or broken, the probabilistic half-line transform will be able to detect them. So as we saw from the previous session where we did the half-line transform, all the lines are drawn across the full screen. But today we'll be seeing how we can explore drawing lines that will not occupy the full space of the screen, as the lane lines that we'll be detecting eventually will not occupy the full screen. It's done using a mathematical formula where you take the theta and the rho value and you do some trigonometry to find the values of the line, right? So today we'll be looking at the half-line transform. So it will take in less arguments compared to what we did previously, where the code will be shorter and it involves more trial and error because we have to tweak the thresholding a bit more. Right, so let's go to the code. So as we know from the Kenny frame over here, the Kenny method will take in a frame. We'll use the grayscale frame, and then the first argument will be the lower bound threshold. This will be the upper bound threshold, and this will be the aperture size. Right, so for this method, we will use the frame, Kenny frame, and we'll pass in the value 1, and then the value of pi over 180, then threshold 100, and then the minimum line length. So this will be the length that is the minimum that will be accepted and then projected onto the image that you want it to. So anything shorter than this line in terms of pixels will be rejected. So we'll just put it at 100 for now, and then the maximum gap between the lines. So we want to set it at maybe say a value of 50 for now. Let's try and experiment with it. So after that, we will try to detect the lines and then draw the lines on the frame itself. So if half line is not none, so that means that if there are lines in the frame, then for the lines in half line, we'll plot the variables, or at least the 4 coordinates. The method of this line. So lines contains elements, but we'll take the first element. So you use the 0 address over here. So what it will, you can print it out and take a look. So what the lines will have will be different elements in it, and the first one is actually an array that contains the 4 coordinates of the line that we're interested to find. So if this doesn't work, because right, so this will be the one that we print out. This will be lines. So let's take the first element, which is the only element, and then these are the 4 values we have. So it coincides with x1, y1, x2, y2. So x1, y1, x2, y2. Then from here, we don't print the lines anymore. We will proceed to use cv2.line to we call the method line to draw these lines on the frame that we want them to be drawn on. So for this one, let's just draw it on the frame, the original frame itself. The next argument will pass in a tuple, which is the x and the first coordinate of the line. Then we'll pass in the second coordinate. It's interchangeable. We can do 2 first, then 1, or 1 first, then 2. But just for the sake of naming, next is the color of the line that we want it to be. So if you want it to be red, let's do this. and this will be the thickness of the line too. So after that, we will normally scale down our frame so it moves faster and it's visible throughout. So we'll just call this let's see how it looks like. Alright, so what we have to do is replace this frame and it should be good to go. Alright, so this is the frame that we had. Sorry, the line is blue actually. So BGR. So we do see a few tiny lines that are imaged. They were then recognized over here. We're picking up a few lines, that's good. You do see a few lines in the bars, in the road, Right. So let's try picking the thresholding around. So for example, we make this, say, E. Let's leave it at 200. And we'll see how anything changes. So we do see that not the lane lines that we want to observe are not being extracted fully. So in future tutorials, we'll look at how we can do more image processing in order to carve out the area of interest that we want, as well as to make the lines more profound, more defined from the background. So all this noise that's going on in the background, for example, maybe a car going past or maybe this road curb over there that might interfere with the kind of lines, the lane lines we want to detect. So we want to detect, in this case, the white lines that run through this over here, as well as this line, so we know where the car is going. So subsequently, we will look at how we can process these images in order to make the lines clearer. Right, so that's it for today's session. If you want to look for the code for whatever we've done and covered today, find them in the description below. And if not, see you next time.